So my name is Anshuman Agarwal. I was basically was supposed to be having Hemant along with me, but he had some, he has to travel somewhere. So my name is Anshuman Agarwal. I'm a specialist for apps, and I basically work with customers to modernize their applications, to work on a lot of cloud native applications which are there. Uh, uh, I have close to around 24 years of experience. Worked in public sector primarily. Uh, I was part of the UID team when in 2010. Then most of the income tax and GSTN and all those frameworks, architectures. I was a principal architect earlier. Um, so been working with most of the government bodies in terms of framing the policies, framing the overall solution around it. So that's been my portfolio for these 24 years. I have a short stint of application development as well for 5 years, and then moved into open source and other things. And with Microsoft, I'm in there for, this is my third year in Microsoft. So yeah. We'll talk about Kubernetes. We have seen there is a growth of Kubernetes containers adoption coming up. So if you see by 2025, we are expecting a close to around 75% increase in container adoption. And that's a huge amount of workload which is going to come in. And what we are seeing traditionally is there is a lot of, because of these adoption coming in, there is a lot of security threats which are also getting imposed into these container environments. And we have to see more from, where there are various things which we have to see from a adoption perspective. How can we bridge those gaps? We have seen during the talk shows today that a lot of focus was there on terms of how do we get these vulnerabilities being captured as part of the deployments when we are doing it. But then there are things where we have to also see that at times as a developer or as a DevSecOps engineer, I may miss out certain things where things cannot be explained to me, or there are vulnerabilities which are coming in every day, and how do I plug in those vulnerabilities as we talk, right? So system should also have certain capabilities in-house, so that it should basically be giving me those threat alerts, so that I can, it should get evoked as we speak, right? So those are things which we have to do. And then there should be also focus on the last piece, which is the shift left policy. While we are developing applications and deploying it on Kubernetes, we have to also see that how do I plug in my security features or security aspects into my development environment itself. So what we typically see when we are developing applications, we normally look at vulnerabilities while we are going into production. And that is the critical part, because when we have vulnerabilities at hand, we typically try to reduce those vulnerabilities by saying that, okay, let's push it to deployment and then we will come back to it, right? So those are things where we have to do it at the development environment itself, that how do I bring in those security layers, so that while I'm checking my code into my source code repository, it should alert me that these are the vulnerabilities. And I have two demos which I will try to show you. One is more on the aspect of, while I'm checking my code, how do I get to know what are the critical vulnerabilities which are there. The second thing is, I'm bringing a flavor of AI into the DevSecOps piece, where I will show you that there are vulnerabilities. You get a list of vulnerabilities, but then as a developer, how do I make sure that these vulnerabilities I can plug in, or how do I fix it, or if there is a code change which is there, how do I get the use of AI to help me build that code automatically for me, right? So those things I will try to show you as part of my shift left policy. So we know that container is images are ephemeral in nature. So these are like read-only images which are there, and the purpose of ephemeral images that you can scale up, scale down. These are small images which are there, and these are immutable in nature, so that once you create an image, you can just deploy it anywhere, because these are images which are ephemeral, and you don't need to do much of changes into it. Once you create an image, you put it for deployment, you move into the entire SDLC lifecycle and move into production, and you're done with it. So every time you create a new image, there are things which you have to see from a security perspective. You have to see that the image which you are creating has a lot of pieces which have been plugged in. So those things you have to see. And then apart from that, there are policies in place, right? I create an image and I deploy it, but then there are certain set of RBAC policies which needs to be plugged in. So those type of visibility has to be created by your system, so that while I'm accessing my application, I should need to know that whether my application has those flows which are there, the RBAC policies which are there, have certain set of defined policies in place, so that I don't need to, I can just try to run them, and if in case there are any vulnerabilities, it should basically give me an alert into it. So those type of things I need to do, and I need to have a complete depth of my entire ecosystem or the landscape which is there, so that I know where the problem statement is. So what we do is, when we talk about these threat vectors which are there, uh, everything starts from your CI/CD when you develop your application. Then you have your Kubernetes platform, which is your web UI layer, which is there. How do I access those? If in case my portal gets compromised, my entire control plane and data plane is compromised, right? So I have to bring in layers of security at each aspect. So one is at the portal layer, I have to see whether my account, I have the right privileges, I am the right administrator to basically access, and I grant those access to, if in case I have certain other team members within my enterprise, I need to basically grant them the limited accesses which they are supposed to function, right? So those type of things I need to do. The second thing is your CI/CD, so that while you build up your application, any image which you are creating, any vulnerability which is there has to be taken care of, right, while you're developing the image, because it's all immutable in nature, right? So that's something which you have to do. The third thing which is there is your environment misconfiguration. So at times what we do is that we create a Kubernetes cluster, but there are version mismatches which are there. I think so everybody knows out here that your Kubernetes is basically a collection of applications, right? You would have a Docker image or your Kubernetes image, and then there would be egress, ingress. These are different packages which are there, right? So if in case there are version mismatch between each of these vulnerabilities, there could be a lot of issues which could be there with respect to your application. So you have to make sure that your all these different application interact with each other, and they are well equipped to basically connect with each other, because there has to be a version compatibility which has to be there, right? So those type of things you have to look at. Next thing is application level attacks. Who can tell me what are the application level attacks which are there? Everybody has heard about SQL code injection, cross-site scripting, right? So those are application level attacks which also needs to be checked in, right? How do I know that, okay, vulnerability is one part of it. I would have a SDK vulnerability which could be there, right? Apache could be vulnerable, PHP could be vulnerable. But at the application layer, if in case there are memory leaks which are happening, if in case there are SQL code injection which is happening, or cross-site scripting is happening, how do I get to know that? So that's one of the critical thing which is there. So your environment should be such that it should basically help you with all these type of vulnerabilities. It should basically throw you alerts that these are certain set of incidents which could happen. And then your node level attacks. Node level attacks are your application, your nodes which are running on these worker nodes which are there. There could be misconfigurations in these nodes itself, right? So while I'm adding another node into my master config file of my my Kubernetes cluster, I basically had configured something wrong, right? Which could lead to certain node level attacks which could happen, right? So those type of things you have to see from a Kubernetes perspective. And then your network level policies, your unauthorized traffic which is coming in, right? You are seeing a lot of traffic coming from a specific IP. I could basically turn it as a DDoS attack, right? So those type of unauthorized traffic has to be plugged in at any given point in time. So these are some sort of threats which basically can happen on your application in your Kubernetes environment, and we have to see how do we fix these up. So, this is how your flow can happen when it comes to attack which can happen in your environment. And typically what we see is that everything is being controlled by your control plane which is there. And when we talk about these, the traffic flow which happens, it is basically your control plane has all these configurations in places, right? And we have to see that whether these we have the right policies being configured over here, more from a cluster perspective, from your host perspective. Those things can be we have to look for. So what we typically see as common attack techniques which are there is, first thing is that the images which you get from you take it from a open source community. There could be vulnerabilities which are there. So one has to see that images are being taken from a trusted source. These trusted source could be you have to see, because what could happen in an image is that I can have a malicious code inside that image as well. So I have to see that whether this particular application is coming in from a trusted code. Second thing is that we have a lot of sidecar containers, because pods are, when we talk about containers, there are pods which are there. There are certain set of sidecar containers which we call them. Those are certain set of policies. Those are not like different containers, but these are policies which are there. So what could happen is that while I'm deploying those sidecar processes, I could have certain backdoor entries which could come in, right? Those are not being defined correctly, which could lead to certain set of exposures which would be there. So while these are certain things which you can see as a common attack in a Kubernetes environment, we have seen these type of things happening over and over a period of time. And what we have also seen very recently is that the digital currency mining, I think so some people would know about it, is that we have seen that a lot of places customers are using Kubernetes environment, and that environment is used for cryptocurrencies. And this is a very critical threat which we have seen in most of the websites which have been running recently. So people have been exposed to cryptocurrency mining on Kubernetes clusters. So this was a very common threat which we have seen just recently coming in. So what has to be done in order to prevent these threats? We have to see that one is that we talk about the execution of container images, because when we talk about, one should not have command prompts or bash prompts available on the container images. You should run them as an exec command, right? So people should not give direct access of the console to the container images. You should run it as an exec command. So there are set of commands which you have to use to basically execute, if you want to execute certain functionality inside your container, right? So those type of things we have to do. Similarly, there are certain set of privileged containers which are there, where you have to run certain set of policies, or there are certain set of containers which needs more preference in terms of from an application perspective. So there are, so you can define those as privileged containers which can which can basically override the main cluster policies and all those things. So those type of threat things which you can do. These are some of the things which you can do in order to prevent your cluster or your Kubernetes cluster from getting you know, you can basically reduce the threat level from your Kubernetes environment. So these are some of the things which are there, but then the list is evolving as we speak, because there's a lot of as we speak, there are a lot of things which are getting developed, and there are a lot of backdoor entries which come into it, which needs to be plugged in every now and then. So as so this is one of the things which we talked about. So if you see what we need to do from a when we talk from a cloud perspective, the main focus which is there is on these four parameters which we talk about. One is the security posture management, where we try to discover what is running as an inventory inside your environment. We see that if in case you're running a Kubernetes cluster, there are certain set of predefined set of policies which get enforced automatically, so that as a 0-day, once you start your cluster, it should basically get implemented, and without any user doing things to it, everything gets implemented. So there's something known as a whitelist type of a policy which comes into play, right? And then the second thing which is there is the vulnerability management, wherein things gets deployed on itself. So it's an agentless type of a deployment, where you don't need to deploy anything on the hypervisor or the host which is there. Everything gets deployed automatically, and then all sorts of scanning happen into it. So it basically complies to your OWASP, should comply to your OWASP and 10 OWASP rules which are there, and then everything should be configured in such a way that it should basically adhere to your 0-day configuration policies which are there, right? The third thing which comes in is your advanced threat detection, which is something where we see every now and then that there are a lot of security threats which are there every time. How can I mitigate those things is where the focus is to basically bring most of the content from the external world. We see that a lot of things which are happening around the globe, those things are being brought in, and as an individual user, you are able to put those things into play. And then your the day two monitoring and deployment happens, where you can scale up, scale down your resources, but that's something which is again another part of the deployment process. But if you see, the first three things which are there are very critical from a container deployment perspective. And when we talk about the first part, which is the posture management, when it detects the inventory which is there, it should basically be able to tell you that which are the set of critical components which are there, and what is the severity level in terms of high, low, or medium which is there. So if you see out here, when I deploy a container image, it within few seconds it will tell me that this is a Postgres image which has been deployed, and it has a very critical impact on top of it because of its high severity which it is showing me, right? So those type of things, it should give me alerts. So once it shows me that alert, I will be able to mitigate those things. I can basically ask for how do I plug those vulnerabilities, and see how I can make those changes into it. So it gives me a complete view of my infrastructure. It tells me about what are the attack paths which are there, if in case I want to check what are the vulnerabilities and how do I fix them. All those things it shows me, and it has a lot of literature along with it, so that I can plug those things as we speak. So those things can be done. Similarly, from a vulnerability management perspective, it basically hooks up to the central vulnerability database which is there. So it will basically tell me about if in case there is any vulnerability with respect to a particular version, or are you using, say for instance, an Apache or any open source package which is there. It will scan and tell me that what is the vulnerability and what is the severity level of those vulnerabilities which are there, right? So that's where it basically pulls up those inventory and gives me the alert in the real time method itself, right? So I don't need to go in and scan them and then fetch them out. So it does that. It gives me a complete insight of my security posture, which is there. Similarly, from a threat detection perspective, it will basically tell me that, whether I am complying to my security posture or not, what is the level of threat which is there. So if I need to know that, whether my environment is secure, or I need to do an audit of my environment, this is the report it will give me in terms of what is the level of threat which is there, right? So those type of things I can, get to know in a real-time fashion, so that I just am secure from zero-day attack, right? So those type of things I can do easily. Moving on, we talked about CI/CD, right? While we are developing applications, we talk about, I am developing an application and I need to just push in my code to my source code repository. And typically we talk about, vulnerabilities coming at the later fag end of while I'm deploying my application. But with, there are various tools which are there within GitHub and other things, where I can basically bring in my security posture during my development during development time itself. So what it can do is that, it can scan for your dependencies which are there, and it can tell you that, okay, whether your environment is secure or not, whether your dependencies are being managed or not, and it will tell you a complete security score of your application. So while you can basically create policies into it, that okay, if in case my security score of my application is not above 95%, it should not be allowed to check in the code into my source code repository. So all those things I can define in my security posture, so that, while developer tries to push in, he has to take approval in place, right? So he has to take approvals, so that, if in case he wants to still go ahead with that. So those type of, things I can do into it, where I can just restrict the dependencies to be taken care of. Second thing is that, uh, how your code is being, saved. Like for instance, typically what we see is that, at most times we see that, your secrets are being sent as a clear text password inside your code itself, right? If you see out here, you have username, you have, your email, your password, and everything been kept inside your application. This can be a very, very severe security threat, because if in case your application is compromised, the code also gets compromised, and anybody can see what your username, password for your database is, or if you're exposing an API, what is the secret of your API, right? So those type of things can be easily viewed. So while you are securing your code, it should also show you that, whether your secrets have been saved in a specific key vault or something like that, where it just uses your passphrase to basically decode the password, right? So those type of things should be brought in. The next thing which is there is something known as code quality. Typically we talk about how good or bad your code is, right? There could be issues with respect to your application code, right? There could be memory leaks which could be there, right? So how do I detect whether my code is as per the legitimate piece which is there? Or there could be, I am using say for instance, I am using a encryption algorithm, say I am using MD5 sum, and MD5 sum has been deprecated, and my system says that okay, this could lead to certain vulnerabilities. So it can basically suggest me that, use DSE or RSA or anything like that, so that I can basically try to use the right algorithm for that matter. So that is where your code quality comes into place, right? So we basically, there is a community which basically manages the code quality as well. So we hook him to that code quality community, and we try to get those things. Okay, and then there are actions which are there. We call them GitHub actions which are there, where you can, if you want to push your code into deployment, say for instance on a cloud or on an on-prem environment, it has various orchestration policies in place, right? So what you can do is that, while you are, trying to push those things, it's a defined template in place, right? You just need to fill in your details in terms of what is the orchestration server IP, your user credentials and all those things, and you can deploy them, right? You can deploy them on a container in platform of your choice, or any other service of your choice which you want to. So those are things which are there. And then it has also something known as a container image scan, which it can do to basically check for what are the issues which are there with respect to the Docker image which is there. So it could be that you're using a very obsolete Docker image which is already having a lot of vulnerabilities into it. So it will tell you that, this is something which is not right, or it is having certain issues which are there. Those can be easily plugged in. So those are things which you can do. So I have a small demo which I will like to show you with respect to so I would like to show you with respect to so I have a small this is a small source code repository which is there, just created it few minutes back. This, what it does is, it's a web application which is there, a Java based web application. It is basically getting containerized. What I'm doing is I'm just using the container image to build it, and I'm just trying to deploy it on a Linux desktop, and that's what I'm doing. So what I have done is I have created a CI/CD pipeline. If you see out here, I have created a CI/CD pipeline. What it does is it basically pulls the source code repository, and then what it does is it scans for the code which is there, and then basis the code which is there, it basically checks for what is the security score of my my deployment. If in case the security score is not met, it will not push it into deployment, right? So once I ran this particular pipeline, it basically prompted me for a issue in terms of my security threats which were there. So if you see out here, it basically sends me a complete security score. If you see, there is a dependency which is there in terms of the Apache common which is there, which has a denial of service attack. And then there are certain out of memory errors which were there. So it basically gives me a high, medium and moderate type of dependency score which is there. And then I do, so I use a code quality which basically checks for my code, how my code is running, how my code is there in terms of, the build quality which is there. It basically tells me that, this has a lot of issues in terms of critical threats and high threats which are there. So it basically tells me about the entire threat vector which is there with respect to my application. So if in case there are any SQL code injections, it will show me all those things out here. So that's where it shows me those vulnerabilities. And then the last piece which is there is my secret scanning, whether my application is using any secrets to store. So it shows me that there is a access token which is there, which is basically using. So if you see out here, there is a secret which is there, which has been saved as a clear text password. It shows me that I can just access that, and I can just put it into a secure vault for that matter, and get this resolved. So that's how I can. It basically alerts me, and if in case my security score is not beyond 95%, it will not deploy it, right? So that's the purpose of this. So it basically threw me an error, and I was being asked to, it was not deployed, right? So that's how it basically does that. If in case I want to do this using an AI, right, the same thing which I want to develop using an AI piece which is there, how do I find and fix a bug which could be there with respect to containers or with respect to an application which is there? I have a small application which is there, I just using Copilot, which is the GitHub Copilot, I just say, can you find the security vulnerability for the selected code? It tells me that it has SQL code injection, cross-site scripting, lack of authentication and authorization, lack of input validation, and insecure password storage, which is there. I just ask them, can you find the security fixes for this particular vulnerabilities which you have listed down? If you see it, basically for each of the line, it will tell me the source code for that, right? I just need to replace that, and I'm done with the entire security scanning of my application, right? So this is where, one is the vulnerability which is there, but how do I cater to the other part, which is my my code injection or my cross-site scripting, which is there, right? Those type of things I can easily do it with Copilot, which is the AI programmed Copilot, which is there. So that's it from my side. Thank you for your time.